morning, students. In this lecture, I am going to solve problems on Fourier, sine and cosine transform, students. Very important topic, students. Let us see. Let us, students, find the Fourier cosine and sine transforms of f of x, that is equal to x 0 less than x less than 1 and 2 minus x 1 less than x less than 2 and 0 x greater than 2. Okay, students, this is one model, students. Previously we done continuous, but here we have some discontinuity, students. Some discontinuity. Right. Solution. First I want to find Fourier cosine transform, students. Right. Fourier cosine transform. Fourier cosine transform of f of x is cosine, students. So fc of s. What, students? fc of s, that is equal to integral 0 to infinity f of x cos sx dx, that is equal to integral 0 to infinity. See, students, this is integral 0 to infinity, students. Okay, integral 0 to infinity. Now you split the limits, students. You split the limits. Where, students? 0 to 1. Okay, students, split the limits 0 to 1 and 1 to 2 and 2 to x greater than 2, students, up to infinity, 2 to infinity. Once again, students, you split the limits 0 to 1, 1 to 2 and 2 to infinity. So you write here 0 to 1, students, 0 to 1. What is f of x value, students, here? X cos sx into dx plus integral, come on, tell me, students, 1 to 2 f of x, students, 2 minus x into cos sx dx plus 2 to infinity f of x value, students, 0. F of x value is 0. So cos sx dx. So this value is 0, students. This value is 0. So apply integration by parts here, students. Integration by parts. Since generalization of integration by parts, students. So integral uv, that is equal to u v1 minus u dash v2 plus and so on. So this is x is u and cos x is v, students. So that is equal to u x integral of cos x, students, sin sx by s, students, sin sx by x minus derivative of x, students, 1 v2 integration of sin sx by s, students. So we get here minus cos sx by s, students. Already we have s, students, so ss square between the limits 0 to 1 plus here u is 2 minus x and v is cos sx, students. So again formula, students, u 2 minus x integral of cos sx sin sx by s minus derivative of 2 is 0, derivative of minus x is minus 1 and again integral of sin sx by s, students. So we get here minus cos sx by s square between limits here 1 to 2, so that is equal to substitute upper limit, students, substitute upper limit. So we get here 1 sin s by s minus into minus plus cos 1 x value is 1, students. So cos s by s square. Substitute lower limit, students. substitute lower limit here. So 0 students, we have 0. So value is 0, minus 0. I am substituting lower limit students here. Minus 3 minus, we get a minus. Cos 0. Cos 0 value is 1 students. So 1 by s square. 1 by s square. Plus. Substitute upper limit students. 2 minus 2, value is 0. Minus 3 minus students minus cos 2s. Cos 2s by s square. Substitute lower limit students minus 2 minus 1 sin s by s. Already we have 3 minus students. As I am substituting lower limit here, 4 minus students, we get plus. So x value is 1 student. So cos s by s square. Now see students here, sin s by s plus and minus sin s by s cancel students. So that is equal to we have here, see students, s 1 by s square, 1 by s square, 1 by s square and 1 by s square students, 1 by s square. So s square is common students, s square. See students, cos s plus cos s students. So 2 cos s minus cos 2s and we have minus 1 students. This is minus 1. Okay students, this is the Fourier cosine transform of given function students. Let us see Fourier sine transform students. Fourier sine transform of f of x is what is first letter students? S. So fs of s, that is equal to integral 0 to infinity f of x sin sx dx, that is equal to integral 0. So see students here, again split the limit students, 0 to 1, f of x value is x sin sx dx plus integral 1 to 2 students, 1 to 2, f of x value here 2 minus x sin sx dx plus integral 2 to infinity students, f of x value 0 sin sx dx. Again apply generalization of integration by part students. So this is u and this is v. So that is equal to x into integral of sin sx students. So minus cos sx by s students, minus formula minus, we have minus derivative of x is 1 minus cos sx by s integration students. So minus sin sx by s, already we have s students, so s square between limits 0 to 1 plus here u is 2 minus x and v is sin x. So 2 minus x integral of sin sx students minus cos sx by s minus derivative of 2 minus x students, 2 is 0, minus x derivative is minus 1, again integration of minus cos sx by s students. So minus sin sx by s, already we have s students, so s square between limits 1 to 2 students. So that is equal to substitute upper limit students, upper limit 1, so minus cos s by s, minus and minus plus sin s by s square. Substitute lower limit students, we have x, so the value is 0, minus 0, sin 0 value 0 students, plus substitute upper limit students, 2 minus 2 0, 3 minus students, so we get a minus sin x value is 2 students, so 2s by s square. Substitute lower limit students, lower limit, minus and minus plus students, 2 minus 1 1, so cos s by s, cos s by s. 4 minus students here, we are substituting lower limit, so 1, 2, 3, lower limit is 4, so plus students 1 sin s by s square, sin s by s square. See students, minus cos s by s plus cos s by s cancel students, so that is equal to see students here, sin s by s square, sin s by s square, minus 2 sin s by minus sin 2s by s square, so LCM is here s square, sin s plus sin s 2 sin s minus sin 2s minus sin 2s. This is the Fourier sine transform of given function students. Let us see the another problem students. Find Fourier cosine transform of f of x that is equal to cos x 0 less than x less than a and 0 x greater than or equal to a. First sum is in terms of x students, algebraic function. Second problem students, trigonometric function. Okay students, right. Solution, Fourier cosine transform students, Fourier cosine transform of f of x is what students? fc of s that is equal to integral 0 to infinity f of x cos sx dx, that is equal to see students here, we have limits 0 to infinity, you split the limits students, split the limits 0 to a and a to infinity. So integral 0 to a f of x students, cos x and cos sx dx plus integral a to infinity f of x value students 0 into cos sx dx. So this value is 0 students. We have like cos a cos b students, so 2 cos a cos b, that is equal students cos a plus b plus cos a minus b, cos a plus b plus cos a minus b. So a is here sx and b is x students, b is x, so that is equal to integral 0 to a. What is missing term students here? 2. So multiply 2 by 2 students, 2 by 2, so 1 by 2 into I want to write here students. So now it is like 2 cos a cos b, so 1 by 2 right, cos a plus b, so cos a sx plus x, taking common x students, so s plus 1 into x plus cos a minus b, so this time cos s minus 1 into x dx, bracket close, that is equal to, say bracket, there is no bracket students, so 1 by 2 integral of cos s plus 1 x students, so sin s plus 1 x by s plus 1 students, s plus 1 plus here sin s minus 1 x by s minus 1, bracket close, between 0 to a, so that is equal to 1 by 2 into bracket sin a students, so s plus 1 into a by s plus 1 plus a students, so sin s minus 1 into a by s minus 1. Substitute lower limit students, sin 0 value 0, sin 0 value 0. So this is the Fourier cosine transform of given function students. Given function. Simple students, whenever given like these conditions, the discontinuity, so you split the limits by observing the conditions students, So 0 to a to infinity. Substitute the function students, function value, and simply integrate students, we get the Fourier cosine transform of given function. If you have any doubt, please comment in the comment box students. Hope you understand Thank you for watching this video. Jai Hind.